Okay, welcome back, guys. We have another question from chapter 4 and another question about the three-dimensional moment. We covered the question in the previous video and we have a very similar question in this one, just a different assembly. And we have this pipe that is subjected to the force F. We have the force F in a vector form, so we know what's the x, y, and z component. And we need to determine the moment of this force about point A. Before we start the question, please make sure to subscribe to the channel and share this content with your friends that might find this helpful. And as always, let me know if you have any specific problem, then we can cover it in the next videos. And let's get started. So for defining the moment, as we have in the question, we need to find a moment about point A, and we will have the cross product of R and F. And obviously all of these are in a vector form, and what we get at the end of moments in 3D questions will be a vector. So we'll have ijk component for the moment. We can start with the r, or distance vector or position vector, and as I mentioned in the previous video, so the r would be any point, any line that connects the point that we are trying to find a moment about, in this question A, to the line of action of the force, and this will be the line of action for the force, which we basically continue the two ends of the force. And any line that connects A to the line of action would be our distance vector. And obviously we're going for the one that is easiest for us to find, and in here, since we have all the dimensions in this question, it seems that the point C is a good point to go. So what we need to find is our AC, and there is another way to show the position vector, and it will be RC/A. So we go with RAC, and F is pretty simple. We already have it in the vector form. So for finding the RAC, all we need to do is to find the coordinates of the ending point, which is C, and subtract that by A. And for this, we'll do this. We have ijk, and we'll have the same thing for A. Let's start with the C. So obviously A is at the origin, so we don't need to be worried about the A. And all we need to do is to find in the coordinates of C, and let's see what we have. So for X, if we look at this, we'll see that we are moving from here to here, and all of these parts are in the same plane. So basically the distance from A to B would be the distance for X component of C, which is 0.5 meter. I'm gonna clean up the figure and we can see the other parts better. there are. Consider is RAC. So first column we have the I component. Again, the second row is always R and third row is F. What we have for I for force. As opposed to dot product, which we get a magnitude at the end. So let's start with the I. So for I, multiplying 0.7 times minus 500 minus 0.3 times 800. This will be our I. The J component, don't forget the negative sign in here. And this time we cover J column, we don't look at it, so we'll multiply these two, and so we'll have 0.5 times minus 500 minus 600 times minus 0.3 J. Again, don't forget this negative sign. It's a part of the formula for finding the determinant. And the last one is what we have for K. This time we cover the K column. And we'll multiply these two, 0.5 times 800 minus 0.7 times 600. That will be okay. So all we need to do is just to calculate this three parts, and if we do that, we'll get minus 110 for I. We get 70 for J and minus 20 for K. The force is in a Newton unit, and all the dimensions in the questions are and you guys please make sure to subscribe to the channel and let me know if you have any specific problem from the three textbooks that we are covering in this channel. I'd be happy to solve them in the next videos. You guys take care, and I'll see you in the next one.